Let me explain how to compress text using LZW compression and decompression. The basic idea of LZW compression is to turn repeated patterns into shorter codes. Let's start. I'll compress this text. Pikachu pinches Pachirisu. We start by initializing a table. The first step is to fill the table with all the characters that appear in the original text and assign an index to each character. For now, keep the output column blank. We start from the beginning with P. P is already in the dictionary, so we concatenate it with the next character, which is I. If the new pattern exists in the dictionary, that means it's already encoded. In this case, PI is not in the dictionary, so we output the code for P, which is 0. This 0 refers to the index of P in the dictionary. Now we are at I. Just like before, I is in the dictionary, so we combine it with the next character, K. IK doesn't exist in the dictionary, so we output the code for I, which is 1, and add IK to the dictionary with a new index. Let's pause for a moment and talk about why we output 0 for a PI, and how this eventually leads to compression. Imagine we have the text ABABC and a dictionary. We start with A. We combine it with B to form AB. Since AB isn't in the dictionary yet, we add AB to the dictionary with a new index and output the code for A, which is 0. At this point, we haven't actually compressed anything yet. We're just preparing for future repeats. Next, we see B. Same process here. Add BA to the dictionary and output the code for B, which is 1. Now we encounter AB again. This time, it's already in the dictionary. So instead of 2 separate codes for A and B, we output its new code 3. We also add ABC to the dictionary for possible future repeats. So after compression, the text ABABC becomes 0132. That's where the real compression happens, when repeated patterns get replaced by a single code. Now, we at K, we do same process. Combine K with A. KA does not exist in dictionary, so we output encode for K. Continue this process with same rule. Here's where it gets interesting. We're at P, and the next character is I. PI already exists in the dictionary, so instead of stopping, we extend it by adding the next character, which is N. Pin does not exist in the dictionary, so we output the code for PI, which is 11, and then add pin to the dictionary with a new index. From here, we just repeat the same steps until the entire text is processed. Now the encoding is complete and our text is fully compressed. LZW compression works even more efficiently when the text is longer and has more repeating patterns. In the next video, I'll explain the decoding process step by step. I'll put the link in the description. Thank you for watching.